Wind farm construction looks something like an ant bed. Stay with me and I'll explain. You and I have an insatiable appetite for electricity. Come with me and we'll look at the issues relative to wind farms and the communities that they serve. This is the Windfarm Guy. Hi, this is Dennis Stout and thank you for joining me for this episode of the Windfarm Guy. This episode will be the 6th part in a series on wind farm basics. Today we're looking at what a wind farm developer might be faced with during construction. Building a wind farm involves a complex sequence of construction activities from planning to commissioning. Here's a breakdown of the key construction phases and activities. The site is prepared by clearing and grading the areas that need it. They'll clear vegetation, remove obstacles, and level the terrain for turbine pads, roads, and other infrastructure. This may involve some tree removal or grading of hills. Permanent and temporary roads are built or upgraded to handle heavy equipment and turbine component transport. Roads are typically gravel or compacted earth and are designed to minimize environmental disruption. They set up construction staging areas, worker camps, storage yards, and temporary utilities like power, water, and sanitation. The foundations are constructed. They excavate the foundation pits for each turbine, typically 10 to 20 feet deep, depending on the turbine size and soil conditions. Concrete foundations are poured and reinforced with steel rebar. Common designs include gravity-based, called spread footing, or pile foundations for weaker soils. Each foundation may require 200 to 400 cubic yards of concrete. Anchor bolts, or cages, are installed in the foundation to secure the turbine tower. These are precisely aligned to ensure stability. The excavated areas around the foundation are backfilled and the concrete is allowed to cure, typically taking 28 days or more. Turbine components are delivered and staged throughout the project. Each of the turbine tower sections, blades, nacelle, hub, and rotor are delivered to the project via specialized trucks or in remote areas by rail or barge. The blades can be 100 to 200 feet long, requiring careful logistics. Components are taken to each turbine site or to a central staging area, ensuring protection from weather and damage. It is preferred to deliver most of the components to each turbine site to avoid unnecessary handling. They'll use cranes to lift and stack tower sections to form the tower, typically 2 to 4 segments, bolting them together. Towers can reach 200 to 400 feet tall. The nacelle is installed by hoisting it onto the tower top with the crane. The nacelle houses the generator, gearbox, and controls, and weighs between 50 to 100 tons. There are 2 ways to assemble the rotor. One way is to assemble the hub and blades on the ground, like the one behind me. Then lift the entire rotor assembly and connect it to the nacelle. The second way is to have the hub pre-attached to the nacelle and the blades are hoisted up to the hub individually and attached. Different turbines and conditions dictate which method is used. As turbines increase in size, I'm seeing more and more use the single blade method. Blades are attached with precision to ensure balance. Large cranes with 500 to 1,000 ton capacities are used, with smaller cranes for auxiliary tasks. Medium voltage collection lines are buried. These connect the turbines to the central collection system. Trenching minimizes visual and environmental impact. A substation is built to step up the voltage to match the voltage at the point of interconnect. This includes transformers, switchgear, and control systems. High voltage transmission lines are constructed to deliver power to the grid. This may involve erecting poles or towers. Supervisory control and data acquisition, or SCADA, systems are installed for remote monitoring and control of turbines. Permanent Met towers are erected with anemometers and other instruments to monitor the wind conditions for performance optimization. The The operations and maintenance, or O&M building, is built. The facility will house it'll house the staff, equipment storage, and turbine monitoring systems. Security is put in place through the installation of fencing, gates, and surveillance systems to secure the site. Mechanical and electrical tests are conducted on each turbine, including blade pitch, yaw system, and generator performance. The turbines are synchronized to the grid, ensuring compliance with grid codes and safety standards. Integration between control and communication systems are verified, that being the SCADA and communication systems for real-time monitoring and control. Final inspections and commissioning ensure all components meet design specifications and regulatory requirements. Disturbed areas are restored by reseeding native vegetation, stabilizing slopes, and mitigating erosion. Road infrastructure is reduced by removing or narrowing temporary roads, leaving only permanent access roads. Project waste is removed, construction debris is cleared, including packaging, temporary structures, and equipment. If you like what I've said today, be sure and click like and subscribe below. If you have thoughts or want me to address a particular topic relative to wind farms, please also leave me a comment. Finally, the project is handed over to the operations team. They transfer the completed wind farm to the operator, including documentation and warranties. O&M staff is trained on turbine operation, maintenance, and safety protocols. Finally, full-scale wind power generation is begun with ongoing monitoring and maintenance. This is Dennis Stout, and I'm the Windfarm Guy. Thank you for watching. Working together, we can make good energy decisions and save our planet. I am the Windfarm Guy.